This button? Yeah, then we will just turn it on if we want to show something here. Turn it on again. Hold it. Okay. Nice. Okay. Yeah. Well, hello everyone. Thank you so much for all being here. I really didn't expect this turnout at a Sunday morning, so yeah, thank you a lot. We are Benny and Mark, and we are developing affordable airborne wind energy systems for everyone. So I'll explain what actually that is in just a minute. But first, let me start with our problem that we have. So the demand for renewable electricity is rising fast, as we all know, but so far the expansion of the electricity production in the renewable area is actually very incomplete, because solar power has become so cheap and simple that everyone can now produce electricity. So does that mean that all problems are solved? Well, no, because what happens if the sun doesn't shine? And because as cheap as producing solar power is, as expensive it is actually to store it so far. So that is why we need wind power. Unfortunately, wind power is very much lagging behind, at least where we are from in Germany. Wind turbines are, if you think about it, the opposite of solar, because they need to reach high enough to reach the wind, and so they need to be as large as possible, and that makes them resource intensive, expensive, and that requires lengthy planning. And also, last but not least, they are not universally loved for their appearance. So what if it was possible to make wind power as accessible as solar power? Airborne wind energy promises exactly that, as it replaces the concrete tower structure and the foundations with a simple line. And we actually know this principle from steerable kites. When it flies in figure eights or circles, you are pulled by the kite. And airborne wind energy systems harvest this energy by replacing your hands with a spool, which is attached to a generator. Reaching higher, where the winds are stronger, maybe even twice as strong as most wind turbines can reach nowadays, is as simple as just buying a longer line. But making this simple concept work is actually not very easy. So far, projects were way too complicated and thus expensive. Like this project from Google, which is for that exact same reason dead now. Large-scale projects, when investments stop flowing in, set the industry back with all the advancement lost. So, well, let's make this simpler, right? We realized for that we need to take a lean and open approach. We start small instead of big, what we can't handle, and we make our advancements open. That secures them and allows participation. 5 years ago, we started from scratch, seeking to do as much as we can ourselves, and based on open source technology, which is already there and doesn't cost anything. So after many iterations and many flight tests, we can autonomously take off, generate power, and land. And our system ended up with basically 10 times lower production costs than other projects, and we achieved that through the lowest complexity by far. For example, we can take off vertically with only 2 propellers. We can land without propellers. Our ground station is exceptionally simple, as you can see there. Additionally, our autopilot is also very simple and very easy to understand and modify for the user as well, and it doesn't need any GPS to know where it is. And we also have very high safety standards based from the concept itself, actually. And we are, for that reason, compatible with air traffic. For example, we can implement air traffic surveillance. We can have the fastest landing by far, so we can avoid obstacles. We have redundant control surfaces, and we have a feature for an autonomous emergency detection and landing. Also, that's the most important part maybe, is the highest flexibility of such a system, because it is portable, it can be deployed in minutes, and the flying area can still be used for any other purpose at any time, basically. And of course, for us here, the most important aspect is we don't secure ourselves any patents, and all electronics and software are open source. So, but how much power can we actually make with this? So, what you see here, this kite generates 1 kilowatt on average and 5 kilowatt peak. And that means the entire energy consumption of one German person, including heating and driving. And if we enlarge the wingspan to 6 meters, we already get 5 kilowatt average and 25 kilowatt peak, and that equals the entire energy consumption of an average German farm. However, this enlargement would not make the production of this system very much more expensive for us. Actually, this would be quite sensible to do, which is why we're going to do that. And so as you can see, the wingspan doubles, the power output multiplies by 5. That's important to know. Yeah. Right.
Okay, let's have a look at this thing actually flying. Here you can see it land autonomously. Here you can see it take off by using its propellers. The propellers, the software is quite similar to quadcopter stabilization.
Yeah, so once the altitude is reached, the propellers will basically just fold in when the power is taken off, and then it can fly efficiently. And after that, we will not use the propellers anymore.
Here you can see it fly figure eights. While it does this, it reels out the line, and the ground station acts like a rowing machine. When you pull out the line, it generates electricity, and as the kite can also fly like a normal airplane, it can fly back against the wind, and the ground station only has to reel in the tether, the line. Okay, let's have a look at the open source hardware and software of this thing. Here you can see the heart of our system. It's a custom-made PCB, including the flight controller. I have a bigger picture here. This is just a common ESP32 microcontroller. Very easy to program. The rest is very simple to quadcopter drones. It uses the same sensors, a gyroscope, a very standard gyroscope, and for the height, it has two altimeters. And on the right side, you see the power electronics for driving the servo motors.
What is the new addition is what's in a circle here, the small pressure sensors are also integrated there, so we can more precisely measure the altitude. That's it, basically. Yeah. Willst du was erklären über Line Angle Sensor?
Ja.
Okay.
Yeah. Here you can see the integrated line angle sensor. We use the gyroscope sensor as a line angle sensor because it has a gyroscope, an accelerometer, and a magnetometer included. We don't need the magnetometer, but because the kite doesn't care where north and south is. The wind can blow from any direction, so we have a magnetometer for free, and what we did is attach a small magnet to the line, and with a magnetometer we can sense where the line goes. This way the kite is able to follow the line when landing, and also while flying figure eights, it knows where the line goes. So it has the angle of the line. We know the length of the line by counting it on the ground station, and so we know exactly where the kite is basically without relying on GPS.
Yeah, we just thought essentially why would we actually control this with GPS like basically any other projects, because there's all the parameters are already defined. It doesn't move freely through the air because everything happens in relation to the line, and the line is where we want to generate power, so why not use that, right? So what you can see here is our setup for the ground station, which is equally interesting, I think.
Yes, the ground station is based completely on the VESC motor controller, an open source hardware and software motor controller by Benjamin Fedder from Sweden. He spent 10 years developing this thing. It's absolutely wonderful and awesome. So some people have replaced their motor controllers in electric vehicles with this one and got something like 50% performance increase. And it's programmable in Lisp, which is absolutely awesome. For our purposes, we need to define the line tension based on how fast the line is reeled out. And this is just one line in Lisp code. And it's just so easy to program this motor controller. It has also some other advantages, like we don't need any additional sensors to count the rotations of the motors. It just senses all by itself the exact position of the motor. It's absolutely wonderful thing to have, and we're really grateful for the open source thing.
To the left is as well another custom designed PCB which integrates another ESP30, or two actually.
Yeah, this is because we need to send, so the VSC counts the motor revolutions and thus knows the line length, and then we send the line length using another ESP32 on the ground station. We send the line length to the kite.
So what can we do with this? Well, first of all, we can, with this setup, we can catch the kite autonomously and it can take off again. So as you can see, it's not perfect yet, but okay. Hast du das hier?
Wir müssen draufklicken.
Ja. As you can see, it will be just catched by this very simple setup, and it can take off again. As I said, it's not perfect yet, but we're testing it currently. So we also, with a friend from the US, we also developed a soft kite variant. So with this soft kite, this will be less autonomous, but as you probably need to throw it up yourself. But this poses great potential, for example, like free time use, and it's going to be much simpler and even more accessible.
And he uses exactly the same ground station as we used. We told him how to build it, and he built it in Montana in the USA without us ever meeting.
And here you can see him operating this at the Burning Man Festival. So our ground station is already very proven in hard conditions, I would say. Here you can see basically the features which our kite has for testing as well as operations. For example, we can edit all the and adjust all the constants of the autopilot, all the settings we can adjust live in flight on our phone or tablet or whatever. And we can demonstrate this here as well. And another feature you can see on the bottom right, which will be more important in the future,